Today I am going to start the rapid revision course, so-called crash course, useful for the completion of syllabus within the shorter duration, and key points of those particular chapters are considered along with the questions in this program. Let's start with the living world topic. Living world, the first topic, 11th class biology, chapter number 1. You know, every living being is complex biomolecular organization and performing various vital activities. That's what is termed as living. There are some properties of living being which is performed by the living organisms, and these properties are actually classified under two categories: defining and non-defining. Defining properties are those which are without exception, that is applicable for all living organisms. Non-defining features are those which are not applicable, or there are some exceptions, not universally applicable, they are with the exception. Property with exception, non-defining; property without exception, defining. And these are the defining properties, that is cellularity, metabolism and consciousness, whereas growth and reproduction are non-defining features. Cellularity in brief, that is all organisms, their body is made up of cell or group of cell, that is uni or multi-cell. Metabolism means that is sum total of biochemical reactions performed by the living being, sum total of biochemical reactions performed by the living being. They may be constructive or may be destructive. That is constructive, that is anabolic reactions, or they may be destructive, that is catabolic reaction. Simple to complex by biochemical activities, anabolism; complex to simple, that is catabolism. And consciousness, that is awareness, that is to sense our surrounding. This is one of the part of every living being, that is it's conscious about its surrounding, responsive about surrounding also. So these three properties are non-defining, and these two properties, growth, they are non-defining. Growth, that is permanent and irreversible increase in size, shape, volume and dry weight. But you know, that is non-living structures can also grow. Suppose deposition of various substances over the hilly area, that is also a type of a growth. Though we can say the growth in living organism is actually intrinsic, whereas in non-living article it is extrinsic, that is it is on the surface only, and by external means, whereas the growth in the living being, that is intrinsic, that is it is an activity performed by them and their protoplasm. Similarly, reproduction, that is to produce own kind. Reproduction means to produce own kind. And in reproduction there are various methods, asexual as well as sexual. Number of methods are there which are described in the NCERT portion also. And you see, organisms around us, they are not able to produce their progeny, like sterile human couple, worker bee, hinny as well as mule. These are the four good examples of organisms, those are sterile, are not able to give birth. That's why reproduction can't be considered as non-defining feature. That's what is kept under non-defining feature. Let's see some questions. First one, Choose defining characteristics of living being. Only defining. In this question, only defining characters are asked. In case first option, cellularity is defining, whereas growth is non-defining. So first option is not there. Metabolism is defining, but growth is non-defining. So this is also not correct. Metabolism and reproduction. Metabolism is defining, reproduction is non-defining. And the last one, cellularity and consciousness. Cellularity and consciousness. Both these properties are defining because they have no exception. All organisms, the body of all organisms are made up of cell. That's why this is defining feature. And consciousness, that is, every organism is aware of its surrounding, or sensitive to its surrounding, and reacts accordingly. That is consciousness. That is consciousness. Question 2. Living organisms can unexceptionally distinguished from the non-living one. Reproduction, some organisms, some living beings are not able to give birth. Similarly, growth is performed by the non-living also. Response to touch, this is the property of living being. But the better one, the last one is better, appropriate, that is interaction with the environment and progressive. This is the unique property of living being, cannot be seen in others. Then we are in this living world, that is, see the diversity. Total number of species till date 1.7 to 1 million. This is the number of different types of species which are already discovered, described as well as named. And such a large number of species is there, so one by one study is not possible. That's why their grouping, their classification is possible. By grouping or classifying them, we can at least know some idea about them. There are two branches. One is taxonomy. This term was given by Candolle, and taxonomy deals with the characterization, identification, classification and nomenclature. This is the taxonomy. Whereas systematics, this term was given by the Linnaeus. Term of systematics was coined by the Linnaeus, and it deals all those things which are under the taxonomy, but he included phylogeny also. Phylogeny, that is evolutionary history, question of number of times. So phylogeny along with the taxonomy is actually systematics. Phylogeny along with the taxonomy, that is called systematics. And what is phylogeny? That is ancestral history or evolutionary history. Then there is another term, neo-systematics is also there. Neo-systematics. In neo-systematics, this is also called biosystematics. Term neo-systematics is given by the Julian Huxley. Julian Huxley. That is taxonomy of modern day. Taxonomy of modern day. That is all features along with the evolutionary history is dealt under neo-systematics. These are the pie charts showing the diversity of organism. If we see this one, that is number of animal species are more than the number of plant species in this living world. Plant species approximate 0.5 to 0.6 millions, whereas animal species 1.2 millions approximate, 1.2 millions. And you see, in animal species, 1.02 out of 1.2. 1.021 out of 1.2. This is the number of insect species. Number of insect species. So this chart indicates the largest group with number of different types of species is insecta. Direct question. Now, question number 3 is related with the previous one. That is approx number of species. While attempting question, please underline the key points, then answer. Here only plant species is asked. They are scientifically named and classified. The answer is 0.5 million. This number is actually approximate number. 15,000 species are every year they are added. I mean they are discovered, described and classified. This is the per year basis addition. Per year basis addition is 15,000 species. And this is the number of animal species. Number of animal species discovered, described and named. And this is total number of species. That is all types of species including plants as well as animal. Total discovered and described. And this is the for the plant species only. This is plant plus animal both. That is all type organism. This is for the animal also. And this is the correct answer, that is 0.5 million. Term systematics. I have already mentioned. That is identification, classification of plants and animal. Nomenclature and identification of plants and animal. In systematics, that is all features along with the evolutionary history. Term systematics was given by the Linnaeus. Term systematics, it was given by the Linnaeus. Actually, this term was coined by Linnaeus. And second thing, taxonomy with evolutionary history. Taxonomy with the evolutionary history. That's why answer 3 is correct. That is, evolutionary history is added for the first time by Mr. Linnaeus in classification. And taxonomy with phylogeny is systematics. Then evolutionary history, that is phylogeny. The specific term for the evolutionary history is phylogeny. Paleontology, that is fossils. Paleontology, that is fossils, study of fossils. And ontogeny, that is developmental studies. Ancestry, that is come to the forefather, closer to this one, but this is most correct, that is phylogeny. Linnaeus was Swedish one. Linnaeus, Swedish. He is Swedish. So let's know about the Linnaeus, then move. Then answer of this question automatically we will get. Linnaeus he was Swedish, born in 1707, died in 1778. So one more question is possible, that is Linnaeus worked in. Linnaeus worked in 18th century. Linnaeus worked in 18th century. This is one more possible question. Then Linnaeus is known for various contributions. He contributed more in biology section. First, known for binomial system of nomenclature. Known for binomial system of nomenclature. Binomial system of nomenclature. Then term systematics was given by him. Term systematics was given by him. Number next, classified organisms under two kingdom system. Two kingdom system of classification. Two kingdom system of classification. This is also Mr. Linnaeus contributed. He wrote number of books actually, out of which few are well-known books. Let's know about them. First one, Systema Naturae. This book was written by the Linnaeus. In this book he described 4326 animal species. 4326 animal species. Discovered, described and named. Then one famous book, Species Plantarum. Another book is Species Plantarum. Mostly these two books are asked. Species Plantarum. In this book he described 5,900 plants. 5,900 plants. These two are the famous book of Mr. Linnaeus. Famous book of Linnaeus. That is first one, Systema Naturae. Second is Species Plantarum. One more book is also concerned with the Linnaeus work. That is Philosophia Botanica. One more book is there, that is Philosophia Botanica. Philosophia Botanica. In this book actually principles of binomials were published. That is, this book has a great contribution, that is principles of binomial. Principles of binomials were given. Principles of binomials. They are seen in this book for the first time. First of all, the answer of this question is Linnaeus. Bentham and Hooker actually known for natural system of classification. Natural system of classification. And Lamarck is known for the Lamarckism. Lamarckism. That is theory of acquired character. Theory of acquired character. And De Candolle is already described, that is, he gave the term taxonomy. He gave the term taxonomy. So Linnaeus is the correct answer for Systema Naturae. Then one very good contribution of Linnaeus, that is binomial system of nomenclature. Binomial system of nomenclature. This is the major contribution of Linnaeus actually. Linnaeus gave binomial system of nomenclature. That is, for the scientific name of an organism, two words are given according to this system. Two words are given according to this system. That's what is called binomial. That's what is called binomial. Bi means two. See, example 1, that is Mangifera indica. See this example. Mangifera, one word, indica, second word. So for the scientific name of an organism, two words are given. That's why it is called binomial system of nomenclature. There are some rules of the binomial system. First word indicates genus, that is in this case Mangifera, genus of mango. Second word indicates species. Second word indicates species. So any binomial indicates genus and species of an organism. That is genus and species of an organism can easily be known by its binomial. Mangifera indica is scientific name of mango. Mangifera is genus, indica is a species. Binomial systems, according to this system, genus is written first followed by species. Second rule. Genus starts with the capital letter. You see species start with the small letter. Species start with the small letter. See the word indica. See the word indica and its spelling starts with the indica I, and I is small here. I is small here. In Mangifera, M is capital. This is according to rule. This is according to the rule of binomial. So scientific number one, genus starts with the capital letter, species starts with the small letter. Then third one, these names are generally from the Latin language. Scientific names are generally from the Latin language. One question is possible, why Latin? Latin is dead language. Latin is dead language, so no amendments are possible. No amendments are possible. But how can we know these words are Latinized? You see, in case of printing of binomial, they are printed in italics. All the binomials are when printed, they are in italics. If we write the scientific name, in case of writing work, how can we know these words are from the Latin language? Let's check and write the scientific name of mango. This is Mangifera, genus, and indica species. Indica species. These names are underlined separately to denote that words are from the Latin. These words are underlined separately to denote these are from the Latin language. This is the only way. That is two things. One, while printing they should be in italics, and while writing the names are underlined separately. Names are underlined separately. So these are some rules of binomial. They are clear cut given in your NCERT book also. Binomial for the plants are approved by ICBN. Number of authorities are there. For plants, ICBN are there. That is International Code of Botanical Nomenclature. The full form may be asked. Then the name of this ICBN is now changed. That is, it is now known as International Code of Nomenclature for Algae, Fungi and Plants. Algae, fungi and plants. And this change was done in 2011 in International Botanical Congress held in Melbourne. So it is also called Melbourne Code. But it is not in NCERT. This is recent information, but it is not an NCERT because it is not revised yet. And for zoological name, that is ICZN is given. ICZN is the authority who decides the scientific name of animals. Then one more authority, ICNCP, International Code for Nomenclature of Cultivated Plants. C for cultivated. That is, suppose a plant, it is used as cultivar or it is cultivated. Then, though it's a plant, ICBN has the authority to give the same name for that one, but specifically it is cultivated plant. So now, these authorities are now responsible for the scientific name of such plants. So it is ICNCP. ICNCP. This is about the scientific name system which is given by the Mr. Linnaeus. Now come to the next question. Binomial nomenclature was proposed by, answer clear cut, that is Linnaeus. Scientific name, that is Linnaeus. Linnaeus proposed binomial system of nomenclature in scientific manner. Though Caspar Bohen is also contributed, Bohen suggested two words name for the scientific name of an organism, but scientifically put forward by Mr. Linnaeus. Other two are not related with the scientific name. The question number 8, ICBN already described International Code of Botanical Nomenclature. This is the correct answer. Then Latin origin, that is, suppose we have written the Mangifera indica. These are actually Latin word. Mangifera indica. These two are the Latin words actually. That is, how can be they indicated? In binomial system, I described that they are separately underlined when handwritten, and in case of printing, the printing is in italics. So these two are right. That's why answer 3 is most correct, both A and B. In case of writing, they are separately underlined, whereas in case of printing, the printing is done in italics. Now, organisms are classified under various categories. Various taxonomic categories are there to classify an organism. I have already described that single or one by one study is not possible of organism. There are number of different types of species are there. So, on the basis of similarity, differences and interrelationships, they can be classified. What are the criteria? Similarity, differences as well as their interrelationships. Even evolutionary relationship is also a criteria. So, these organisms are kept under certain taxonomic categories. These are the different types of taxonomic categories, and these are the 7 obligate categories. 7 obligate categories. These are the 7 obligate categories given by ICBN. These categories were given by the ICBN, that is International Code of Botanical Nomenclature, and they are arranged from lower to higher or higher to lower. This is taxonomic hierarchy, that is from low to high. Taxonomic hierarchy, that is they are arranged in ascending order, and when they are arranged in ascending order, the main criteria is similarity. In that case, what is considered? similarity. When we arrange organisms in these category or classify organisms in these category, then similarities are taken. Whereas in descending order, differences are taken. Similarities reduce when we move from species to kingdom. Whereas differences increase when we proceed from kingdom to species. Kingdom to species, when we move, what increases? That is differences increases. Highest category kingdom, lowest is species. The species, group of species, group of related species, there is definitely some similarity between them. Then they are kept under genus. Similarly, group of related genera constitute family, group of related families constitute order, group of related order constitute class, then phylum and division. There is a question here. See here, the question is there, that is phylum and division. They are the same category, but one is applied in plant and other one is applied in animal classification. That is next to kingdom. When we move downward, then there is a category phylum. Phylum is applied in animal classification. Phylum category is applied for animal classification. Phylum applied in animal classification. Whereas division is applied in plant classification. It is applied in plant classification. So these two are the same category, phylum and division. Phylum and division are the same category, and phylum term is applicable in animal classification, whereas division is applied in case of plant classification. And these are the some suffix specially used with the plant classification. These are the some suffix which are used in plant classification, not for animal classification. This is word phyta, not phy. This is a phy actually. Phyta. Phyta. Phyta is the suffix for the division. Phyta suffix is for the division. For example, bryophyta. You see phyta suffix is written in this word. Pteridophyta. One more example. Pteridophyta. It indicates division. Pteridophyta indicates division. Sorry. How can we know this is a division? You see, suffix phyta is added. Now, physi for class. Physi word is for class. When we study about the plant classification, you see in algae there is a class chlorophysi. See this word, chlorophysi. In algae classification, one class is chlorophysi. Chlorophysi class. This class is for the green algae. And how can we know this is a class? See this suffix, that is physi is added in this one. Physi is added. So chlorophysi is a class. Chlorophysi, rhodophysi, pheophysi. In all these words you see suffix physi. Now third one, ales. else is used with the order. In plant classification, else suffix is used to describe order. For example, sapindales. One very good example you'll see in your NCERT books while studying the mango classification. Sapindales. This is an order of mango, or we can say the mango is kept under this order. This is the order you can see by this suffix. Now, in family, ACEAE is used. Suffix ACEAE is used with the family. Let's take an example. While studying the mango classification and second one, that is classification of wheat. In NCERT book, two examples they had taken, one for wheat monocot, another for the mango dicot. And family of a mango is Anacardiaceae. Family of mango is Anacardiaceae. See the suffix Anacardiaceae. ACEAE is used. Similarly, wheat family Poaceae. See, AC is again there. That is ACE suffix is used for the family. This is all about the taxonomic hierarchy. And these are the categories. They are not denoting here organism. These are the taxonomic categories only. These are taxonomic categories only.